Welcome to Jason's Electronics Repair. We are back with some electronics here, guys. We're going to talk about fuses and resistors and why you use a fuse over a resistor with a little visualization. Well, words are difficult today. So anyway, we're back doing a little bit of teaching electronics, a limit of what I can do. I'm not going to get into the extreme details of what's going on, but hopefully this content amuses you. Let me just take this off here. Boom, we have iCircuit. Very simple representation of a circuit. We have a 5-volt DC source here. We're producing 5 volts. We have a 220 ohm resistor, and we have an LED with a 2.1 voltage drop. And as you can see here, the LED is lit up with the 220 volt or 220 ohm resistor. Wow, 220 volt resistor. That's hilarious. So a resistor is going to be something that's going to limit the current dependent on the voltage present here. So we have a 220 ohm resistor, and Ohm's law tells us that the voltage is equal to the current times the resistance, and then you can inverse that to get any of the formulas that that you need. We're not going to get into all of Ohm's law today, but we have our little meter that is off the screen here. That's quite annoying here. Hold on. There we go. So as you can see down here, we have across the LED, we have 1.826 volts dropped across the resistor, and we're cruising about 14 milliamps. Now, if you have a circuit that has a fuse that is designed to protect up to 1 amp, you could also have a resistor that restricts the current down to 1 amp. Currently, we are using this resistor to reduce the current in this circuit to 14 milliamps. 15 to 20 is what you want in LED. This applies to any generalization of a singular circuit. Parallel and series resistors would change that. We're not getting into that today. Specifically about fuses and resistors. So as we change the value of this resistor, as you can see, the resistor is dropping 3 volts, and then we're making up the other 1.8 on the LED, so we have our full 5 volts of drop. But as you can see here, we have the 14 milliamps, and if I lower the resistance to, say, 70, we are 43 milliamps. We have a very bright LED. We still have 3 volts dropping across the resistor, and we still have 1.8 volts dropped across the LED. But again, we have 43 milliamps, which is more than we need. If we had a 25 milliamp fuse, a fuse would have blown in this situation. So let's go back up to our 220. No, this is, okay, the resistor. We need to crank back up to 220. So we get this back up to 220. It's been a long time since I used this program. So we're back down to our 14 milliamps. But what happens, and we're like, oh, okay, good. So if I want 14 milliamps on my circuit, I put a 220 amp fuse and 220 ohm resistor in there. But if I change the voltage to 10 volts, say we have a surge of 10 volts come through, double the voltage. If you look, we're at 36 milliamps. If we had a 25 milliamp fuse, that fuse would have blown, and the circuit would not function anymore, and we would not have this amount of current being sunk into our LED or the rest of the circuit. So replacing a fuse with a resistor is not the best solution, because a resistor will limit the current dependent on the voltage present. So if you have a surge, or you have an increase in voltage, and also if you have a decrease in voltage, say down to 2 volts, you're not going to light the LED, because you're still getting a voltage drop across that resistor, where a fuse would not see the voltage drop, and you would have the correct voltage dropped across with the optimum amount of current. Now with an LED, you still need a resistor in line, but this is simply to discuss the blowing of fuses and why replacing a fuse with a resistor is not the best thing, because normally a fuse blows when there is a surge of voltage that increases the current level of the circuit, which is outside the tolerance of the fuse, and that fuse blows. With as a resistor, the resistor would just produce heat and allow a higher amount of current to flow through the circuit. Now, I don't have fancy fuses in this system, but you can imagine a fuse like a switch. So if I put this in here, now the circuit's off, and then if I close the circuit, it flows, and then if too much current enters the circuit, the fuse opens and the circuit is perfectly fine. Just key points here. A fuse is made to allow the current, to allow an amount of current regardless of the voltage. So it is set to a rating 1 amp, 2 amp, milliamps, whatever the rating is, no matter the input voltage, it will always contain that rating. And if it exceeds, if the voltage allows a current to be produced that exceeds the rating of the fuse will become open. There are resettable fuses that, if the voltage returns the current level to a level within the rating of the fuse, it will operate again functionally. Some of them need a complete loss of power before the fuse will work again, depending on the complexity of the resettable fuse. So there's also slow burn fuse, fast burn fuse, and that's a little bit more than we're going to get into. They are not resistors. Fuses are not resistors, but they work in similar ways. Limiting the current with a resistor will produce heat. Using a fuse to set the current limit will only produce heat if the current value is higher than the rating. What a fuse is a tube or a component similar to an SMD resistor that has a thin piece of wire in there that has a resistance value. So again, very similar to a resistor. And when it is designed when a certain amount of current flows through this thin piece of wire, it heats up the wire and the wire breaks. There are other mechanisms for current for fuses, but in a simple form, this is what we're discussing here. So it just completely opens the circuit. Then when the fuse is replaced, it closes the circuit. So that is why a fuse is not a resistor. So I hope to share some more short videos on different components and the comparisons, transistors, capacitors, different digital logic circuits, and all that good stuff. But I will not keep any more of your time. Take care and have a fantastic day.